Hello, my dear students. Welcome you all to Sri Jayendra Rank Zone classes. I am your mentor and your friend for the subject chemistry, and I will be dealing with organic chemistry. My dear students, today we are going to start with hydrocarbons. In this session, we will be learning about the types of hydrocarbons, the composition of hydrocarbons, and their different theories of origin which is proposed by different scientists. Apart from this, we will also be discussing about certain terms and terminologies mainly associated with hydrocarbons like octane number, different characteristics of hydrocarbons. So let us start with the general introduction of hydrocarbons. So first of all, that what is hydrocarbon? So basically, organic compounds composed of only carbon and hydrogen are called hydrocarbons. Are called hydrocarbons. They are of mainly two types. One is aliphatic, as the detailed classification of hydrocarbons or organic compounds we have discussed in the chapter IUPAC nomenclature and general organic chemistry. So specifically hydrocarbons, they are of two types: aliphatic hydrocarbons, which mainly includes alkanes, alkenes, and alkynes. The second category is aromatic hydrocarbons, which includes arenes. Now, first of all, we are going to talk about that what are the different sources of aliphatic hydrocarbons. There are different sources like mineral oil or crude oil, petroleum, it is the dark color oily liquid with offensive odor found at various depths in many regions. Found at various depths in many regions below the surface of Earth. Okay. It is generally found under the rock of Earth's crust. Under the rocks of Earth's crust and often floats over salted water. Floats over salted water. Okay. So petroleum or mineral oil, crude oil, they are the most common sources of aliphatic hydrocarbons. Okay. Now, the composition. Composition of petroleum products or crude oil. Firstly, it mainly consists of alkanes, which is around 30 to 70%. Contains up to 40 carbon atoms. Alkanes are mostly straight chain, but some are branch chain isomers. Mostly they are but some are branched chain isomers. Okay. Secondly, cycloalkanes. They make 16 to 64% present in petroleum. Most common of them are cyclohexane, methyl cyclopentane, cycloalkanes rich oil is called asphaltic oil. Cycloalkanes rich oil is known as what? Asphaltic oil. Then comes aromatic hydrocarbons like benzene, also known as arenes. They make 8 to 15% of petroleum. Examples are benzene, toluene, xylene, naphthalene, etc. Fourthly, sulfur containing compounds like mercaptans, sulfur or nitrogen containing compounds, containing compounds, sulfur containing compounds 6%, mainly in the form of mercaptans, RSH, The unpleasant smell of petroleum is due to sulfur compounds. Sulfur compounds. Okay. Nitrogen-based compounds include pyridines, quinolones, and pyrroles. Oxygen compounds present in petroleum are alcohols, phenols, and resins. Compounds like chlorophyll, hemin are also present in it. Are also present in it because they are fossil fuels. So they basically include dead and decaying remains of organic compounds, including animals as well as plants. Okay. Petroleum also consists of natural gas. Natural gas, it is a mixture of 80% methane, 13% ethane, 3% propane, and 1% butane. Vapors of low boiling pentanes and hexanes are also present. 0.5% of low boiling pentanes and hexanes. Liquefied petroleum gas mainly consists of butanes and pentanes, and it is used as cooking gas. It is highly inflammable, mainly consists of methane, nitrogen, and ethane. Okay. Then comes the composition of compressed natural gas (CNG). When natural gas is compressed at very high pressure, it's called compressed natural gas. Natural gas has octane rating of 130. So it mainly consists of methane and may contain small amount of ethane and propane. Okay. Then we are going to talk about the different theories of origin of petroleum. Mendeleev, carbide theory or inorganic theory. Secondly, Engler's theory or organic theory. And the third is modern theory. The fourth point, which is included under the composition theories of origin of petroleum, is mining of petroleum. The process of artificial drilling, the mining of petroleum is done. Then fifth one is petroleum refining. Separation of useful fraction by fractional distillation. The process uses fractional distillation. Okay, which is used for petroleum refining. Now, the purification of petroleum includes treatment with concentrated H2SO4, okay. The gasoline or kerosene oil is shaken with concentrated H2SO4 to remove aromatic compounds like thiophene and other sulfur compound. Okay, helps to remove aromatic compounds like thiophene and other sulfur containing compounds. Which impart offensive odor to gasoline and kerosene and also make them corrosive. Under the purification, the second is Doppler sweetening process. The mercaptans, sodium plumbide, disulfides, lead sulfide, different fractions are passed over adsorbents like alumina, silica, or clay, which are when the undesirable compounds get absorbed. Okay. The third treatment is treatment with adsorbents like silica, alumina or clay? See, silica, alumina, clay, they basically absorb all the gases or compounds on their surface. This process known as what? Adsorption. Okay. Now, the next is artificial method for manufacturing of petrol or gasoline. Of petrol or gasoline. The first step is cracking. Second is synthesis. Cracking is the process in which high boiling fractions consisting of higher hydrocarbons high boiling fractions consisting of higher hydrocarbons okay to break them into lower hydrocarbons. Cracking is carried out in two different ways. So basically, the process of heating high boiling fractions consisting of higher hydrocarbons is broken down in the presence of heat to form lower hydrocarbons. And the two ways for doing this is first is liquid phase cracking, and the second is vapor phase cracking. Okay. In liquid phase cracking, the temperature range which is used is 475 to 530 degrees Celsius. Okay. So basically, heavy oil or residual oil is cracked or heated at a high temperature of 475 to 530 degrees Celsius under high pressure around 70 atm. Okay. The high pressure keeps the reaction product in liquid state keeps the reaction product in liquid phase. Okay. The cracking, it can be done in the presence of some catalyst like silica, like alumina, silica, etc. Okay. Second is vapor phase refining. Vapor phase cracking, sorry. In this process, kerosene oil or gas oil is cracked in vapor phase. It's cracked under vapor phase. The temperature is kept 600 to 800 degrees Celsius. Okay. And the pressure is 3.5 to 10.5 atmospheres. The cracking is facilitated by use of suitable catalyst, which yields a percentage about 70%. Okay. Now the synthesis is done by Burgess process, and second is Fischer-Topaz process. In Burgess process, coal plus hydrogen, iron oxide means Fe2O3, 450 to 500 degrees Celsius temperature, and 250 atm pressure. Mixture of hydrocarbons. Fischer-Tropez process. The overall yield of this method is slightly higher than Burgess process. Okay. CO plus H2. Mixture of hydrocarbons. The best catalyst for this process is a mixture of cobalt, hundred parts, thoria 5 parts, magnesia 8 parts, and Kisilgur 200 parts. Okay. Now we are going to start with characteristics of hydrocarbons. First is knocking and anti-knocking. The metallic sound during working of an internal combustion engine is called knocking. Produced by internal combustion engine. Okay. The greater the compression, greater will be the efficiency of engine. Will be efficiency of engine. Okay. The tendency to knock falls off in the following order. First is straight chain alkanes, maximum, then branch chain alkanes, then olefins, then cycloalkanes, then aromatic hydrocarbons. Okay. Second is octane number. These are characteristics of hydrocarbons. Octane number, which is very important. It is used for measuring the knocking character of fuel. Okay, it is used to measure the knocking character of fuel. Used in petrol engine. The octane number of a given sample may be defined as the percentage by volume of isooctane present in a mixture of isooctane and N-heptane. Which has same knocking performance as fuel itself. N-heptane knocking is 0. While isooctane is having octane number 100. For N-heptane, the octane number is 0. Octane number is 100. For example, in a given sample, the knocking performance equivalent to a mixture containing 60% isooctane and 40% heptane, then octane number of gasoline will be 60. equivalent to a mixture containing 60% isooctane and 40% heptane. So the octane number for isooctane is 60. Okay. Octane number of gasoline means petrol can be increased by, in case of straight chain, octane number decreases with increasing in the length of the chain. Inversely proportional to length of carbon chain. Next, branching of chain increases the value of octane number. Octane number. Introduction of double bond or triple bond increases the value of octane number. Multiple bonds or unsaturation increases octane number. Cyclic alkanes have relatively higher value of octane number. Okay. The octane number of aromatic hydrocarbons are exceptionally high. Okay. By adding tetraethyl lead. Okay. Now we are going to talk about anti-knocking compounds. Compounds which help to reduce the knocking property, okay, or to improve the octane number of fuel. Certain chemicals are added like anti-knocking compounds, among which tetraethyl lead is one of the compound. Tetraethyl lead, TEL. It basically consists of 63% ethylene bromide, 26% ethylene chloride, and 9% tetraethyl lead is 63%. Okay, so sorry. So tetraethyl lead is 63%, ethylene bromide is 26%, 9% of ethylene chloride, and along with that a dye is also there, okay, 2%. There is one major disadvantage of using tetraethyl lead, which leads to the deposition of lead in the engine. To remove the free lead, ethylene halides are added with combine with lead to form volatile lead halides. Disadvantage of adding tetraethyl lead is free lead gets deposited on engine, which is scrapped off, okay, by adding ethylene halides. Plus to form PbX2. Okay. Nowadays, to overcome the lead poisoning, a new compound cyclopentadienyl manganese carbonyl is used. Another name AK33X is used as an anti-knocking compound. Okay, cyclopentamagnease carbonyl, pentadienyl manganese carbonyl. Okay, these are the different methods of removing knocking agents. Okay, cetane number. It is used for grading the diesel oils. Grading diesel oils. Okay, it is the percentage of cetane, that is hexadecane, by volume in a mixture of cetane and alpha methyl naphthalene. And alpha methyl naphthalene. Okay. Next term is flashpoint. The lowest temperature at which an oil gives sufficient vapors oil gives sufficient vapors to form an explosive mixture with air. Explosive mixture with air. Okay. Flash point in India is fixed at 44 degrees Celsius. Flash point of an oil is usually determined by Abel's apparatus. My dear student, this is the introduction of hydrocarbons. In the next turn, we will be starting with paraffins, that is alkenes. Okay, till then, bye bye, take care, stay safe, stay healthy.